How would you explain SLIM, structures for lossless ion manipulations, in plain language to those people who are more familiar with LCMS?
Yeah, so SLAM is the technology I referenced that we licensed out of PNNL, and it is an ion mobility technology. And what that means is that we're creating ions like you do in mass spec. You have an ionization source, and then we're doing a gas phase separation of those ions. And it's interesting how there are a lot of analogies to what you think about in terms of chromatography, where we can translate that into what we're doing in the ion mobility world. So we talk about things like peak capacity, and instead of retention time, we talk about arrival times of ions. We also have an analogy to gradient elution. So when you're changing your gradient mix, your solvent mix, we can ramp our voltages that we apply and achieve a lot of the same tricks of making chromatography better, but we do it in the ion mobility space. And so I would really think about it as another type of chromatography, just that we're doing it on ions with voltages instead of achieving that separation based on a stationary phase and a mobile phase. So that's really the best corollary. And the way that we do SLIM is often integrating it with LCMS. We're plugging this additional method of separation into the instrumentation between the LC separation and the mass measurement. And so the instruments we're building are LC ion mobility mass spectrometers, and adding that technology into the workflow provides a number of advantages in the measurements we can do. And just one other corollary to chromatography is we think about chromatography is driven by the kinetics of the interaction of these molecules in the liquid phase. And because we're doing the separations in the gas phase, the kinetics are different. It's the gas versus liquid effect, where the separations we can do are actually 1,000 times faster. So if you're normally doing a 20, 30-minute LC run, that same type of a separation we can often do 1,000 times faster. So it's on the time scale of milliseconds to seconds. And so it's nice how that meshes, and we're able to still do the full resolution LC data collection and then collect these slices in the ion mobility domain to add this additional dimension of separation.